Okay, so as we're looking at chain drives now, kind of, if you would, shifting gears, chain drives start on page 276. And as we know, a chain drive is going to be made up of a chain and a sprocket. Okay, a chain and a sprocket. So the chain is going to be the power transmission element made up of a series of pin connected links. And roller chain is going to be our most popular. So I'm going to kind of bring this one back out underneath my camera. We looked at this a little bit earlier and we saw roller chain. Okay. For those in the room, you can come and grab this from me and kind of look at it. There's some other sizes in here too. Now, roller chain, as it says, it's going to be, oops, my link fell, sorry. It's going to be the most common. And as we saw earlier, the teeth on the sprocket are going to fit in between each one of these rollers. Okay, the rollers are going to be, attached together through those side plates. And then the teeth of my sprocket are going to fit into those. So it's a match set. You have to have the right sprocket to go with the right size chain. Okay, and when we have a chain drive, we are going to be specifying the sprocket for the input, the sprocket for the output, and then the chain, the total chain that's going to go over the top. Okay. All right. If we look at page 278 and illustration 733, we're going to see an arrangement here, or a picture of an arrangement where we have the sprocket of the input, sprocket of the output, or the high speed, low speed, and then the chain going over the top. Okay. So let's look at roller chain. So roller chain specifically is going to be identified by its pitch. The pitch is going to be the classification, and it's going to be in pitch numbers. In kinematics, we actually talked about this in detail, and we picked chain pitches. But just as a review, we're going to look at table 712, where they have the chain pitches identified with corresponding average tensile strengths. So underneath here, table 712 are US roller chain sizes, and the chain sizes are going to correspond to numbers. And those numbers then are going to have a distance in inches called pitches. Now, a chain pitch is going to be the distance from one feature on one like roller to the same feature on the next roller. So as we look here at our chain, if I would measure from, if you would, the center distance of this pin to the center of distance of that pin, that will be my pitch in inches. So the physical distance. So you'll notice here, as my numbers get larger, so does the actual pitch in inches. It gets to be larger, thicker, chunkier type of chain. Now, over on the right-hand side, you're going to notice the average tensile strength. So as these chains get larger, you're able to then, stretch them more. They can take more tensile strength. We turn the page to page 281. We're going to notice up on the top a couple different types of arrangements of chains. Now, at the top is going to be the typical standard roller chain. The next one here is going to be roller chain, but in this case, we have two strands that are coming together. Okay. Now you can have 3, 4, maybe even more chains that are going to be ganged together, and they offer higher strength in an application. Here's heavier duty chain, and that's just going to be thicker side plates and rollers. Double pitch chain, so you kind of lose that one that's in between there. And then you'll also notice one of the features of chain is that you can take these side plates and pins apart, and you can design in them different elements to help you move product along. And in this case, you're going to notice it's like a bar. Maybe it's going to move some product along a conveyor or, some sort of a platform. The next one that we see here is it's a V. Maybe we're going to set down in there something that's round, and it's going to stay in that position until it's going to be taken to another. And you can have another configuration like that. And chain is nice for that because you literally can take it apart and then add these accessories to do some of these like automation types of functions. Okay, so chain is very versatile that way. Oops. Okay. The design of chain drive. So there's two modes of failure that we're going to be concerned, or three modes of failure that we're going to be concerned about with chain drives. First, the failure of the link plates due to tension. So if we are pulling those apart, those link plates, the plates that are on the side there, can actually fail. Okay. Another one is going to be the impact of the rollers on the sprocket teeth. Over time, it just kind of wears away as it runs. And then also that very same thing, the galling of the pins and the bushings that are in there. So those are going to be things that we would be concerned about failures as we're designing. Now, horsepower rating charts. The horsepower rating charts or tables are going to be found starting on page 283. And there are three different sizes here, and they're going to help us to determine the appropriate chain for an application. So if we look underneath, and when we do our example, we'll be referencing back to these. On page 283 is our first chart. This chart on the top is for number 40 chain, which corresponds to a half pitch chain, meaning a half inch is going to be between, if this was a number 40 chain, look on it. Sometimes they have it stamped on there. This is a number 40 chain actually. So this is going to be a half inch pitch. So if I would determine the distance between the center distance of this pin to that pin, that's going to be a half inch. Okay. So that's the physical size of it. Now in the chart here, these are going to be, as it says on top, the horsepower ratings. These are all the numbers in the inside. And we are going to use the column that corresponds to the rotational speed of our smaller sprocket, or our faster rotating sprocket in revolutions per minute. And we're going to find where our horsepower is. Now, ideally, when we read any type of chart and we're sizing, we kind of want to land in the middle-ish, okay? If we're up at the top or at the bottom of the chart that we're looking at, we are going to be at one extreme or the other. If we're at the top, it means that we might be in an application where our chain might be a little big for the actual application. But if we end up on the bottom, that means that we're probably stretching the limits of what that chain can actually take. And we're on the other side, you may want to consider going to a larger chain. So if you look at the numbers here, they're kind of ranging, you know, in the middle-ish. We've got from 2 to, I don't know, 15, 16 horsepower, kind of in the middle here. If I turn the page, you're going to notice we're going to go up a size. This is going to be a number 60 chain. So that's 3/4 inch pitch. And now you'll notice these numbers just got considerably larger in the middle of the chart. And then lastly, we're going to have number 80 chain. This is even larger. This is going to be 1 inch pitch. So again, those numbers are getting larger just because of the nature of the chains getting bulkier. Okay. Additionally, on these charts, you're going to notice that we have kind of these lines, these stair steps, and they correspond to 3 different types at the bottom. There's type A, type B, and type C. So if we're in the type A part, there's actually this one white line and type A right here. This is going to be the type of lubrication. Okay. The first one here is called manual drip lubrication. And if we end up here with our specification, then that's the type of lubrication we're going to need to design into our machine or our application. The next one is the largest area. This is going to be the bath or a disc lubrication, and that's going to be kind of on the left-hand side of the stair step. And then anything over to the right of that is going to be an oil stream lubrication. And we'll see that in just a little bit, but those 3 elements we get off of our charts. Okay. And we'll be using these in the example that we look at as well. Now, the horsepower comes from the chart itself, but if we end up having to use more than one strand, just like we saw with the belt drives, sometimes one isn't going to do it. We're going to kind of gang these together or put them together so that we can get more out of them. And you'll notice here that when I have one strand, it's going to be the value that's on the chart. But if I start needing 2, 3, and 4 strands, they aren't going to be multipliers by 2, 3, and 4. We actually have a factor of, for 2 strands, 1.7. And then for 3 strands, 2.5. And then 4 strands, 3.3. The reason for that is when they put these together and they make multiple strands, the multiple strands are going to be like a solid chain, if you would. So we end up losing a side plate in the middle. And so we compromise a little bit on that tensile strength because of that. Okay. So that's the reason for that. So you can't, if you end up needing multiple strands, you can't use, the 2, 3, and the 4 factor. You need to use the ones that are listed. And those you can find on page 181. They're actually listed in the book there. Yeah, you could, but you're gonna have that'll be, because then you would get a sprocket that would accommodate the 3 or the 4, and then you would have just like you would be much wider, because then you'd have a hub and everything on it too. So yeah, you could. The ratings have a service factor of 1. Okay, so you're going to be applying that service factor if it's something different than 1 according to your application. So if we look at page 286, you're going to find table 717, and we've done this a couple times for different applications, and this helps us to kind of customize it, if you would. So we need to look at the type of driver. So this is going to be our input. Is it a motor? Is it an engine? Whatever it might be, a hydraulic drive. And then we look at our load type. This is going to be the machine, the output that we're looking at. And so we're going to line up the driver type to whatever the load type is. And then this is going to be what we call our service factor that we're going to be using. So we've done this on the gear designs. We've done this on the belt designs. So we're seeing it here again. And it just helps to, kind of let us know what is the chance of something either overloading or jamming or going awry, if you would. Guidelines for chain design. So as we look here, I want to kind of go through these because these are going to be things we're going to consider as we, fill in our design for the problem we're going to do in a little bit. So, so you'll notice here that it says the minimum number of teeth is going to be 17 unless the drive operates at 100 RPM or slower. Okay. The maximum speed ratio should not go over 7. So if you need something more than 7, you're going to want to split that up and have multiples, or maybe consider gearbox or something else. Okay. The center distance should be between 30 and 50 pitches. Okay. Pitches is going to be one individual, section of that roller chain. So a pitch underneath here is just going to be one of these. So chain comes in like bulk rolls. So if you are, utilizing chain, you'll usually get it on a spool, kind of like string. And when you are getting it off, what you'll do is you'll count individually each one of these pitches. And so we are going to be sizing, and we're going to be specifying length in pitches. And that's what it's getting at here. So I'm sorry. So when we look at center distance, depending on the pitch in inches, we want it to be between 30 and 50. So for instance, if I have 1 inch pitch, that means that my center distance is going to be between 30 and 50 inches. If I have a 1/2 inch pitch, that means it's going to be between 15 and 25 inches. So, so it's based on pitches, not on inches. The arc of contact should be no smaller than 120 degrees. Okay. And that's going to be, you want it to be as much as possible. So the more arc that you have of engagement, the more teeth that you have engaged. And that's only going to benefit the application so that it's stronger. So if I go back underneath here, that angle is how much that angle of wrap, if you would, of that chain. And we don't want that to go underneath 120 degrees. Okay. Larger sprocket, no more than 120 teeth. The center line's horizontal is ideal. It doesn't have to be horizontal, but it is ideal. And then they talk about the tight side on the top. What does that mean? Tight side on the top is going to be in the direction of rotation. So if this is our driver and it's going in a clockwise manner, it's pulling the teeth along. So the top is going to be the tight side. And then as it goes on the bottom here, that's going to be the slack side. You maybe have seen chains as they wear, they stretch out just like belts do. And what happens is that starts to sag underneath. Okay. So you sometimes see that slack side, a little bit of a sag there, but this is going to be the tight side, and we want that tight side to be on top optimally. These are design guidelines. Center line horizontal. The chain length must be an integer number, and it has to be even. And even is recommended. I'm sorry. So the chain length, as I said earlier, is when we count the pitches coming off of the spool. So that has to be an integer number because we can't have a half of a pitch. And then it says here too, an even number is recommended. And that's really just to be sure that the same teeth aren't always going on the same roller. And then lastly, check the manufacturer's minimum number of teeth on their product. They might have a different minimum requirement. This is just, by the industry, these are guidelines. Okay. So lubrication. So lubrication, we already saw on the charts where we're going to see what's going to be appropriate for an application, but the different lubrication types are going to be found on page 287. 287. So here are the 3 different types of lubrication. The first one is just called a drip feed lubrication. This is called type A. So we have to have somewhere along the, the placement of where the chain drive is, we need to have lubrication dripping directly on the chains. The next ones that we see here, there's 2 different versions here. These are going to be shallow bath or disc lubrication, and that's where one of the sprockets actually goes through that bath, and by the nature of the chain and the teeth itself, it's going to kind of pick up that lubrication, and then it's going to lubricate the rest of the chain drive. And then the last one that we have here, this is going to be an oil stream lubrication. So again, we're going to have it going directly onto the chain itself, and it's going to be a continuous stream of oil in this case. You'll notice that on the charts, as we worked from A to C in any one of those, A is kind of like the lesser duty, B is like the medium, and C is going to be the more heavy duty. Okay. So, so making sure that you understand which type of lubrication type is going to need to be built in is really important. Okay. And that's going to also affect the life of your chain drive.
What's that? Is that the only place that the heat permitted is located, or is that?
I'm certain it's in the book. Just have to find it. The lubrication, so figure 736. I know I wouldn't have gotten that from nowhere. 36. Hold on 1 second. I'm gonna resume. I didn't resume. So, so we're gonna stop here because what I'm gonna do is I'm gonna have a separate recording for just this example. So if you need to go back to it, you can go to that specifically, and then we'll kind of look at any additional questions that you might have as we go through. So I'm gonna stop.